less than 2 hours from now. This is Mission Control Houston.
EVA2 will be conducted on Flight Day 7. The crew members for this EVA are EV1 Steve Swanson and EV3 Joe Acaba. Their first task will be to egress the Quest airlock and translate over to the top of the U.S. laboratory module, where we have a couple of foot restraints stowed. They'll each collect a foot restraint and put it on their body restraint tether for translation out to the far side of the International Space Station, to the P6 element, which is way at the other end of the station from where they were working on EVA1. They'll translate out past the port Sarge, or solar array rotary joint. That joint will have to be locked until they've completed task on the outboard elements. Their first task is in support of preparations for the 2JA mission, which will be flying later this year. They'll position 2 foot restraints and a couple of gap spanners for support of body restraint and translation across the Integrated Electronics Assembly, or IEA, where the 6 batteries that will be changed out on the 2JA mission are located. You can see here the handrails for one of the gap spanners and the handrails for the second gap spanner that will span the deck of the IEA as they do their work. On STS-119, our crew will be releasing the high torque on the bolts of the 6 batteries that will be changed out on the later mission. Those bolts are torqued down to 55 foot-pounds for launch, and in order to make sure that they're each the torque can be broken and they are ready to go for removal and replacement on the next mission, our crew will be using a ratchet wrench to break the torque on each one of the 2 bolts on each of the 6 batteries. When they are finished with this portion of the EVA, they'll pack up their tools and translate back inboard across the port Sarge to their next task, which is deployment of the UCAS, or Universal Cargo Carrier Attach System. This UCAS will be used on the ULF-3 mission to position an external logistics carrier that will provide spare parts for maintenance on the ISS for the duration of the program. In order to deploy this UCAS, there are 2 braces that need to be removed that provide structural support to the Sarge and the outboard elements. That's the Sarge brace that you see moving there, and the diagonal brace across that section of the P3 element. They'll be moved out of the way so that the UCAS can be moved out of its launch location inside the S3, and then the braces have to be put back into location, bolted back, the diagonal and the Sarge brace, both bolted into location, before the yoke of the UCAS can be brought down into its final location and mated to the deploy clevis bracket using an adjustable diameter pin and a pip pin to hold it in place, as well as the 4 fasteners that secure the deploy clevis bracket to the S3 element. Acaba will be photographing some damage that we have on the starboard radiator of the primary thermal control system. Here you can see there's a sheet of covering of that radiator that has pulled loose. We want to get good photography of that. This is a picture of our infrared camera, or IR camera. We'll be using this camera to take thermal imagery of the entire radiator, both sides of that radiator. The ground will command a complete flip of the radiator halfway through so that we can get IR images as well as digital images of that radiator. The digital images must be taken during daylight, so we'll have to be careful about our choreography to make sure that we've got daylight available for at least a portion of the time that we are looking at that radiator. Then crew member Acaba will turn around and do the same infrared photography and digital photography of the port radiator Again, looking to see if any of the same kind of damage or delamination of the coverings of those radiators may have occurred. While he's working on that imagery, EV1, Steve Swanson, will be translating out to the Japanese portion of the International Space Station, to the JLP, and installing a GPS antenna, or global positioning satellite antenna, on top of that element. That GPS antenna will be used to provide redundancy for docking of the HTV logistics carrier, which is supplied by the Japanese, to the International Space Station later this year. You can see him here in the Neutral Buoyancy Laboratory working on making connections for that GPS antenna. When he's finished with that task, he'll translate back over a little bit closer to crew member Akaba, back on the Z1 element, where he will be working on a patch panel reconfiguration that will provide redundant power to the CMGs, or the control moment gyros, that are located under that large gray-looking thermal blanket right in front of him. He'll be attempting to demate and mate a connector that's been giving us trouble on a couple of the last missions. The ground controllers have looked at the possible failures along with the engineering team. The engineering team's made several suggestions on techniques that may help to be able to move that connector. If that connector doesn't move, we've got a backup plan to go to the back of the panel, actuating some backup connectors to make those connections. From here, the crew will be translating back over to the starboard side for another deploy of an element that's very similar to the UCAS. It's actually called a PAS, or Payload Attached System. To you and I and the EV crew members, the interfaces look exactly the same on a UCAS as they do on a PAS. And the operations are the same. Removing the SARG and diagonal brace to get them out of the way, followed by deploying the PAS from inside the S3 element to outside, and then reattaching the diagonal brace and SARG brace. Finally, bringing the yoke of the PAS assembly down into position to the deploy clevis bracket, securing it with an adjustable diameter pin and a pip pin, and the 4 fasteners on the deploy clevis bracket. Both the P3 UCAS and the S3 Zenith outboard PAS will be used on the ULF-3 mission. The crew